The following video recording has been made possible by Robotic, complete warehouse automation. From integrated supply chain consulting to fully automated picking systems with progressive financial models. Robotic systems are deployed in major grocery, retail, and general merchandise operations throughout North America. Learn more at Robotic.com. And by Duchin Productions, broadcast, corporate, and web video production services specializing in science and technology. Start the conversation today. Visit DuchinProductions.com to learn how video can get your business the customers, talent, and investors you've been looking for.
I'd like to talk about something kind of weird, robotics. You have never heard of this. So the guys shown here, there's 2 legs and 2 arms, and at the shoulder, the 2 extra arms, third and fourth arms. Surprisingly, just a new future. These extra limbs could be incorporated into your body, and you feel that, well, I have extra limbs, and it's just perceived to be just extension of your body. It sounds very weird, but again, surprisingly, you find big business opportunities along this line, which I'd like to share with you. So, yeah, this is a kind of a human augmentations, and me and the corner rows, and then many speakers today will focus on. So the typically prosthetics or exoskeletons. Our labs have been exploring a third type of kind of wearable robotics, that is to add extra limbs to your body. I'd like to start with something really, practical applications shown here. I'm sorry, this is not the healthcare, but I'll include that one. Shown here is airplanes final assembly. And how many of you have ever visited the final assembly site of airplanes, big airplanes? This is over $300 billion industry, creating over $80 billion trade surplus. It's a very important industry yet. If you see this, it's all depends on the manual labors. It's a handcrafted stuff. And then also, if you look at these guys, these are working on the floor. The other guys are working on the ceilings. Taking pretty bad postures all day long. It leads to some great. So this is our solution. Okay. So I want to talk about this type of wearable extra limbs in 2 contexts. One is the manufacturing, the other is the healthcare. And if I have a little bit of time, I'd like to talk about something going beyond the academic work, incubations and commercializations and such. So again, looking at this, let's first focus on the jobs. Guys are working on the floor, and what they do is take this kind of a posture all day long. They have to take a rest every 30 minutes, otherwise get the troubles. You see in the other areas, a bunch of works, people are working, picking up strawberries, or working on the construction, the stooping and all the time, or heavy duty, heavy industries that they had to do some floor work all day long. Now, if you look at the manual tasks, it seems to me there are three types. One is that there's something that you can replace by industrial robots by tweaking those and affect some little intelligence. The second type is the kind of jobs are so dedicated and then highly depends on the human skills. It's not likely you can replace it at any time, 20 years or 30 years from now. And the third type is somewhere in between. We can just, so-called, co-robotics that can be applied to it. Now, what I'd like to do is to focus on the second type, okay? It's not actually replacing the workers, but we support the workers. This is class 2 tasks. As I said, there are many things, and if we can actually support the those workers properly, ergonomically correct way, then we can increase the productivity, reduce the human errors, and decrease the risk of injury, so forth. This is our solutions. We put a pair of robotic arms attached to the chest area. Something like with this, you can free two hands, so you can actually do something what you need to do. People don't want to be like this, but it's really, we call it a mantis bot. So I'm taking this kind of difficult posture, you get the concentration of stress here and here. So what I'd like to do is extend this. Before extending this, so perhaps you can just see something something like a kneeling chair like this. That's actually the best posture. And then you lean forward this way, and then you need some kind of support, and then we put this guy. So this is the kind of robot we can actually support the human body. This is not just a static rigid body support. So a worker can move as he wants sideways. It's being supported stably. If he just turn off the servo loop, then he crash. So you can actually see how it works like this. So it is the body is being supported kind of compliantly, and with invisible cables from there, its body is stable, and then actually systems is absorbing the stability. So even though he tried to reach this point on that side, stability is maintained. So this is not the your favorable exoskeletons. Exoskeletons are good to increase the joint torques. But looking at this kind of task, this is actually kinematically wrong. I mean, our body is not designed for performing this kind of task, right? So even though you increase the joint torques here, it doesn't help. So exoskeleton can't solve this. You need to have extra limbs, extra kinematic structure that is to support your body stably. So that's my point. Putting the heavy items on the body, you feel something not so much practical. In fact, 5 years ago, when we started this is the machine that we built, 35 kilograms in the total. We really assisting the workers or loading the workers. But a good thing that we have reduced the weight and further, it's about 3 kilograms or 6 DOF. So that's the things that we're using the advanced, added manufacturing. Now, switching the gear a little bit towards the now fingers and healthcare. This person has 2 extra fingers, so he has 7 fingers. We focus on the hemiplegic patient support. So he got the stroke some time ago, and now his left hand is totally numb, being trained this way. We found that this is actually MIT's students who built this simple things. Just putting the 2 extra fingers, we can actually do the job. Another interesting stuff we found is that they want to walk, but they can't actually hold the walker stably. But if you put the 2 extra fingers, this side can hold the rail, so both sides can hold this one stably. So even this a simple thing that they really appreciate. I mean, the patient really appreciate. How many minutes we have? Just a couple of minutes. Okay. Let me just skip this one. But no, the challenge is how you communicate with the fingers and with the extra, robotic fingers. So we did some kind of this academic work. So then don't worry. But we just did it in a very data-driven way. You use this guide, and what sort of posture you would like to prefer. We take a bunch of data, and they did some kind of data science type of analysis, and we found some particular way of relating 5 fingers with 2 fingers in terms of the, kind of principal component analysis and so forth. The first 3 components can explain this very well. So the challenge is that how can I actually coordinate these robot motions with the hand-finger postures. We measure this a little bit, and then actually robot infer what is the desired configurations. We use some data analysis techniques. It turns out just 3 principal components, 3 partial least squares modes can actually generate the whole control here. So we just put the little sensors, and we can actually do some task as shown here. So this is the first mode, first principal component, and then robot fingers react to it, and then moving to a second mode, it can actually do this kind of job. And altogether, it's interesting. You just try to, and hold some object, and take some particular posture for your 5 fingers, then robot hands understand what is the desired posture. So here we go. So just so you naturally reach it, and then robot fingers carries this one accordingly. Extending this, you can open the option here like this. Let me just skip. Yeah, so like this kind of stuff. Now, I just want to spend 1 more minute. This wearable gripper can be actually simplified and reduced to some commercially available products. The challenge is that actually MIT work is always complex, but simplified, pick up a particular set of functional requirements that definitely needed, and then we can produce some commercializable products. We are targeting the process. So this is actually, you got the stroke, and then half of your body is just numb. After some training, you can recover this, but over some time, 3, 4, 5 months, recovery process is saturated. And then this time, and finally, you can't move the fingers or have a little limited mobility here. So if we put a little bit of help, reaching at this point with the extra fingers, they can live independently. So that's what we are doing. And in this case, this is a little old, prototype. But this person actually immobilizing the whole fingers there. Can actually do the by manual task where you need to use the 2 hands at the same time. People try to actually, recover this one by putting lots of rehabilitation stuff, but unfortunately, those things can saturate. And those patients are not abundant. Actually, they have to, their insurance is terminated, and they have to leave the hospitals, have to go to nursing homes, skilled nursing homes, which is very costly. So this is something to fill the gap in between 800,000 patients every year. We have this kind of program. So we tested out with a bunch of stuff and you see at home. And it turns out, unlike the MIT research, very simple design and a very simple way of controlling this that can meet the stuff. So the conclusion, wearable extra arms, legs, and fingers open up new possibilities of robotics and manufacturing, and not replacing people, but we can assist them. And this one, at least politically correct stuff, because we still hear that robots and people fear that actually they take our jobs. Yeah, the exactly same an argument that we heard many years ago. It's still there, but this one we can talk to labor union. We can talk to the people who are really working there, and they appreciate it. So this is something interesting direction. And healthcare, simplify the device like this. It may be an alternative approach to some. Rehab equipment is very costly, so we can actually do something else. With that, I just conclude my talk. Thank you.